Hello everyone. We're going to talk about domain and range. And before we do that though, there's something to keep in mind is that we have to know what a relation is. And the reason why I say that is because the domain is really referring to the x values and the range refers to the y values. And when we talk about a relation, we want to know the relationship between those x's and y's. Okay, because if we know the relationship between the x's and the y's, we can determine what patterns are forming, what kind of function it's going to create. Because when you think about it, if you have a set of points, right, each point is a coordinate, and you know that a coordinate has an x value and a y value, an x coordinate and a y coordinate. And if you have many coordinates, okay, we want to know the relationship between all the x values to all the y values, because we want to know that because we want to see what kind of function is being graphed or plotted out, and that can tell you a lot about the relationship. Okay, so when you think about a relation, I want you to think of a set of coordinates, okay? And, the best way that I could probably represent that is that, remember, each coordinate has an x and has a y, but it's important to understand in a relation that between two sets, you have a collection of ordered pairs, okay? So in mathematics, a collection is represented by a set of braces, okay? And it's a set. So what this is basically a set, okay? And if you remember, a set is a collection, okay? It's a collection of objects, okay? Like if you were to collect a set of baseball cards, right? Each baseball card is an object or an element of that set. Well, in this case, we're talking about ordered pairs, okay? So, we'll pick some ordered pairs, okay? And each one has an x and a y coordinate, okay? So, we have all these coordinates, okay? In a set. And we want to know what the relation is between every single x to y, every x to y, every x to y. What is the pattern that's going to form? Okay? In other words, if one value is increasing, what is the other value doing? Is it increasing? Is it decreasing? And that can tell us a lot about a relationship between any two things that we want to compare. Like, for example, height and temperature. The higher you go into the atmosphere, right? The higher and the more height you go, all right? The more altitude that you gain, the temperature decreases. So as one value increases, then the temp decreases, okay? Just think of something like that. But essentially, if you have a set of coordinates, we want to know the relationship between all those x's and y's, okay? So that way we know what's going on. So let's go to the next page, okay? So we'll talk about domain, okay? Domain. Okay, and the domain is referring to a relation of all the x values. Okay, so we're going to say the relation refers to all x values. Okay, and then the opposite would be for the range. Okay, if you have the range, then the relation that we're going to be talking about is going to refers to all y values, okay? Whoops. All right, so the domain is referring to the x values, and the, let me just make sure we understand that, okay? The x values, and the range is the y values, all right? So it's kind of important to realize that, okay? So an example, okay? So let's say you had, a set of coordinates, okay? And I'll give you real numbers here this time. All right. So we got 3 and 4, 5 and 6, 7 and 8, and 9 and 10. All right. So inside this set we have 5 coordinates, okay? And basically we want to know the domain. Well, the domains of this function the domains are all the x values, okay? So remember, this is your x and these are your y's, okay? So if you go ahead and identify them so there's no question on what values I'm referring to, the domains are all the x values. So basically 1, then you have 3, then you have 5, then you have 7, then you have 9. All right? So all the x values are represents the domain. Okay? And the ranges are all the y values, okay? So again, you have 2, right? And you look at the second coordinate, you got 4. Third coordinate is 6. Fourth one is what, 8? And the last one is 10. All right? So the range would be representative of all of those values, okay? So it's pretty straightforward. The domain is the x values, the range is the y values. So that is the most important thing that you can keep in mind, okay? So if you're given a set of coordinates, then you just recite all the x's and all the y's. Now, you don't repeat x values that are the same. So if you have if you have 2 coordinates, you know, if you have 2 x values that are 1, you don't necessarily repeat them when you recite them in the domain. Okay, you just pick one of those ones to represent both of them, or however many times it's repeated. Now, when certain x values repeat and certain y values repeat, then the relation is going to change depending on what value is being repeated. Okay. The key thing to remember, to keep this really simple, okay, is that go back to what a function is, okay? So when you do a function, okay, you know, if I break down what a function is, right? You basically have all right, a function can, the notation for a function is f of x, okay? So when you have a, which means a y value, okay? So you could say either y or f of x, okay? So an example of an equation, okay, and it doesn't matter what it is, I'm just gonna pick something really easy, okay? So let's say you had, you know, y equals 2x, okay? All right, so the x value, okay, remember, is referring to the input. And that's also known as the domain, okay? Because remember, the domain is the x value. So you can also refer the x values as the input, while the y is going to be the opposite. It's going to be the output. And that's referred to as the range, okay? Does that make sense? Okay? So what goes in the function, okay? Whatever value goes in for x is going to generate one y value. And that's a true definition of a function. One input should generate only one output. So if I go ahead and, substitute a value of, y equals 2, and let's say x is 1 in this case. Well, my input is 1, so let's evaluate that. What's 2 times 1? Well, that's going to be 2. So therefore, my y value, or my output, will be 2. So this is what my coordinate will look like, 1, 2. That is what the coordinate looks like, x, y. Okay? And you notice that when x is 1, I should only get y equal 2. In other words, if I plug in one x value, I shouldn't get more than one answer. I should only get one output, one answer. So if one value, if you see a function, if you see like an x value in a function, right? And in this case, let's say it's 1, and it's generating this different y values at the same time, then you know that can't be a function, okay? So, for example, this was a function. We said this was a function, okay? Because you have a different x for every different y value. When x is 1, y is 2. When x is 3, y is 4. And I'm referring to these points on top here with the very first set, 1, 2, 3, 4. That's where I'm referring to. You notice that each x is producing one y value, and that's it, okay? And that is what you have to remember, all right? So if you see a situation like this, okay? So let me see if I can create a situation where, we have a function, where we don't have a function. That's what I wanted to say. Okay. So let's say we have 10, 15, and the other one is 20, 45. The other one is 30, 25, and the other one is 40, 35. Okay? So, I want to know if this is a function. Okay? Is this a function? Yes or no? So, the way that I like to look at it is, I like to draw a mapping, like map it out. So let's list all the x values, okay? So we have 10, the next one is 20, the next one is 30, and the other last x value is 40, okay? So these are my x values, all right? And then let's correspond let's see, 15, okay, and then you have 15, yeah, 15, I'm losing track here. Okay, sorry. I'm looking at the other coordinate. The first one is 15, okay? So the second one would be 25. I'm going to, okay. So you got 20, then you got 45, then 30, and then 25, and then 40 and 35. Okay? So when you map these out, you're going to clearly see that, and these are the y values, by the way. Okay? You notice that each x value correlates to a different and only one y value. Okay? So there is no multiple productions, like when x is 10, it's only producing 15. When x is 20, it's only producing 45. When x is 30, it yields 25. Okay? So that's definitely a function. I mean, that's definitely a function. So that would be yes. Okay? That's a yes. So you want to say yes. Okay? Because for every one input, there's exactly one output. All right? And that's called the mapping. Let's say I gave you the mapping. Okay? So let's say you had, again, this is your, when I say your x this is the input and your y is your output. All right? So let's say you had 2, and let's say you had 4 and 3. Okay? So that's going to be my one area here. The other one's going to be 20, 30, and 40. All right. And let's say I draw my arrow. So let's say 2 produces 20, and let's say I told you it produces 40. And then 3 is going to be for 30. And 4 is also going to be a 40. Okay, so is this a function? All right, is this a function? Okay, so let's evaluate how each x correlates to a y, to the y. Okay, look at the first value of x. Okay, remember these are your x's and these are your y's. Okay, so look at the 2. 2 is an x. It's producing 20, and it's also producing 40. So it's paired with more than one y value. Okay? And right off the bat, that fails the definition of a function. So it is not going to be a function. It's going to be a big no. Just on that one fact alone. Okay? All right, 4 is yielding 40 and 3 is 30. That's okay, but this x value 2 is producing 2 outputs, 20 and 40, and that can't happen, not in a function. Okay? I mean, it's not considered a function. I mean, it can produce, in other words, if I plug in 2 into an equation, let's say the answer is 20, then I should get 20, not 40, or not both of them. Okay? It's got to be one or the other. So that fails as a function. Okay? Let's do another mapping. Let's say I gave you A, B, C, and D. Okay, and then we have X, Y, and Z. All right, and I'm going to give you the mapping. Okay, so how does this work? Okay, and be careful when you analyze this one because remember these are your x's, these are your y's. So remember when I say x, I mean input, and then the y is referring to the output. All right. So look at x yields y, right? B yields y, and so does C. Now you're probably saying, well, that can't be a function because it's you got 2 different values producing the same one. Actually, it's kind of like what I just said. You got 2 different values. Remember initially, I said if you had one x value producing 2 different y values simultaneously, that can't happen. But if you look at this situation, A produces x, that's fine. B produces y, And then C, which is a totally different input, can also produce a same value of y. That can happen as long as the inputs were different. Okay? So let me just, this input and this input are different, even though it's producing one y value. Okay? As long as the inputs are different, then it can yield the same y value. That is possible. Okay? So this one, okay, all right, is a function. Okay? So we want to know if it's a function or not. Okay? But we said yes. Yes. Okay? And that's the key trick. All right? In the previous slide, if you have a situation where you have A, B, and C, and D, right? And you have these, let's say you had X, Y, and Z. So let's say you had this situation where A is producing X, B is producing X. That's okay. Okay, that's acceptable. But what you can't have is this. This, C producing Y and then C producing Z. That can't happen. That's a no. This is a no, and then this would be a yes. Okay. Now, again, so remember, in order for it to be a function or not, you have to have one of these situations occurring, not at the same time, okay? So I'm just showing you an example of you can have two different x's producing the same y, which is fine, but you can't have one x producing two different y's at the same time. So I just want you to compare the difference, okay? This is not a function because I have two situations at the same time. I was just only explaining that difference, okay? So just kind of make sure that you understand the difference between that. And that's all it is to it, okay? So another cool thing with this is that if you have a graph, okay? So let's say you had a graph and you want to know if it's a function. So let's say you just had this as a graph. Whoops. Right? And this is your x, and this is your y. And I want to know if it's a function, okay? So what we do is we do the vertical line test, okay? And you just draw it through the graph vertically. And then you just ask yourself, does it intercept the graph one time? And it certainly does right at that point. And no matter where you draw the vertical line, it's only going to touch the graph at one point. So this is called the vertical line test. Okay? Vertical line test. All right? And you can test any function with that. So another one would be this, right? Let's say you had this one. Okay? And let's say you had a circle. And you want to do the vertical line test. Well, if you do the vertical line test, you notice that I have two interceptions, actually right there. Actually, let me go ahead and use a different color so you can see it. See the two interceptions right there? This one only had one, so let me go ahead and make that point. All right, so here it crosses the graph more than once. And what does that mean? That means that if you look on the x value, whatever this x value is, where the red line is touching the x-axis, okay, that means that when x is that value, it's going to produce a value where the first green dot is on top, and then another value is exactly below that. And we said that one x value should not be producing two simultaneous y values. And that is why that's not a function. So no matter where you draw the vertical line test, it's going to intercept that graph more than once. So it's going to fail. So this is not a function. So we said yes, this was a function, but this one was a no. okay? Same thing this, and doing one more. If you had this one, right? Let's say this is my graph. And I do a vertical line test. Well, this intercepts that parabola twice, so that fails right there. So it's not a function. If I draw a vertical line here, okay, it's still going to fail. Okay, so I'll do it again. It failed. Okay, no matter where I draw a vertical line, it's not going to be a function. So that would be a no. All right. So visually, you can easily test whether something's a function or not. Okay. Another good example, we'll do one more down here. Okay. And let's say I have some points. So we'll just draw some points. Then we'll do another one here, and another one there, and another one there, and maybe one over here. Okay? And I want you to pay attention to this one really carefully. I need to draw a vertical line through every point, and you're going to see why. Watch what happens, okay? So let me make these a little bit bigger. All right. And we'll do a vertical line test, okay? So looks like it intercepts that point once. So far it's a function. Here we're good, that's a function. We're good, that intercepts that at one point. But notice what happens here. Look, these 2 points are on the same vertical line. So right there, that fails. Even though every point passes, unfortunately, that's not going to make it a function. So that's going to be a no. All right. So pretty easy to do when you do the vertical line test. Vertical line test is extremely helpful. All right. Highly, if you have a graph already made, you don't need to write all the points down. You can just look at it and say, yep, it passed the vertical line test function. Oh, it didn't pass it, and it's not a function. Okay. So, and it's always a vertical line test, not horizontal. That's something different. Okay. So, just a quick, analysis of domain and range. Okay. And then of course, oh yeah, there's actually one more thing. Actually, I'm going to go to the next slide, and I'm going to give you 2 graphs. Okay. The first one is going to be this. All right, so 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Okay, so let's say I gave you a graph. Again, this is -1, and this is 1. Okay, and this is 2. Okay, just so you know what the scale looks like. All right. So let's say you had a graph like this. All right. And this is your X, and this is your Y. And you want to find the domain. Actually, you want to find the domain and range. Okay? So the domain, in order to find the domain graphically, you have to think of the X values or the X axis and the relationship to where that graph is with the X axis. All right? So, in other words, if I put an X value, or I should say when I put X values, okay, I want to make sure I get all the X values that produce Y values that will be on that graph. Okay, so look where the graph begins. The graph begins at -1. All right, and then it bends down to the right, and then it goes on for in the infinity direction, positive infinity direction, okay? So when you do the domain, okay, when you do the domain for that, the domain, okay, we'll just use D for domain, okay, is going to be from -1, because that's where the graph is. In other words, the lowest x value that I could put in is -1. And then my corresponding y value will of course be, 0. Okay? So think about that, all right? So this coordinate right here is when x is -1, my y value is 0, and that I cannot put any x values past -1 because I'm not going to get a corresponding y value that's going to be on the graph. The graph does not go past -1. So the domain is not going to be past -1. It's going to start at -1. And we're going to include it. And that's why we use brackets. If you remember interval notation, we use brackets if we're including the x value. Okay? And then it's comma. And then you notice the graph goes into the positive infinity direction. Okay? So it's -1, comma, positive infinity. And we always use parentheses around infinities. Okay? So, as a little tidbit, okay, you always use parentheses around negative infinity and positive infinity. All right? All right. And if we're including a value, then we use a bracket. If we don't include a value, then we use a parenthesis, okay? So the domain is -1 to positive infinity. That's where all the corresponding x values, okay, will have to be, okay? In other words, if I plug in +1, I'm going to get a corresponding y value on the graph. When x is 2, I get a corresponding y value. When x is 10, I'm going to get a corresponding y value. When x is 1 million, I'm going to get a corresponding y value. As long as it's -1 all the way to positive infinity, I will definitely be on that graph. Okay, the range is the y values. So what is the minimum and maximum y values that I could put in where the graph will show up? Well, look at the y value. The y values is the y-axis. So you got to be looking vertically up and down. Don't look left and right on the x-axis anymore. We're done analyzing that. I want you to look at all the y value. The y value, okay, whoops, sorry about that. The y value, the most you can put for y value, the graph does not go above the y-axis at 0, okay? So you have to think visually here. The minimum y value you get is 0, and that occurs at -1, okay? So the range is going to start at 0, okay? And we're including it, okay? Comma, okay? All the way to negative infinity. Okay? Because the highest y value that we can get is 1, and that's only going to occur when x is -1. So when as you increase the x, when x is 0, okay, at the origin, you're going to get a corresponding y value below the x-axis here. You're down here, okay? So let me just note that, okay? So when x is 0, you're going to get a y value down here. When x is 1, you're going to get a y value down here. You notice these y values are negative. When x is 2, you get a y value here. When x is 3, okay, when x is 3, whoops, doesn't want to stay. When x is 3, you get a y value down here. Okay, when x is 4, you get a y value down here. You notice that's a negative y value. So that's why it's negative infinity. Okay? So another example is, let's say you had this. okay? And this is your x, this is your y. And let's say the graph looks like this. So we're going to do tick marks here. Whoops. 1, 2, 3, 4. So we'll call that 2. And then these go up every 2. So that's 4 and it's 6, right, etc. And then we'll do the same here. This will be 2. This will be 4. This will be 6. This will be -2, -4, -6. Now let's say we have a graph right at 2. Like that. Like that. All right? And I want you to find the domain for me, okay? Again, what x values I can choose so that I'll get a corresponding y value. Well, think about it here. Okay, this is a cool one. When x is 0, my corresponding y value is going to be right at 2. When x is 2, my corresponding y value will probably be a 4. Okay? When x is 4, my y value is probably going to be a 6. Okay, my graph might be a little off because I'm freehanding it here. But you get the point, right? No matter what positive x value I get, I'm going to get a corresponding y value. When x is -2, then I'm going to get probably a y value here. When x is 4, I get a y value here. When x is 6, I get a y value here. And you notice the arrows on the graph, meaning it goes on forever and ever and ever. So no matter what x value, what negative x value I get, or what positive y value I get, including 0, I'm going to get a corresponding y value to the graph. So when that happens, you're going to say the domain is -infinity, positive infinity. Again, we always use parentheses around infinities. Okay, so that means we could substitute an unlimited amount of x values, and I'm going to get a corresponding y value for each one of those x values we substitute in. Okay, and my range is going to be, what is my lowest y value on the graph? Well, if you think about it, when x is 0, y is 2, and that's a key point. So let me go ahead and put that here, okay? When x is 0, my y is +2. So my lowest y value is going to be a 2. And we're going to include that because it's on the graph. So we use a bracket. All right, that's the low. That v makes a point at 2, and that's the lowest y value that goes on the y-axis. That v goes to 2 on the y-axis. That's as low as it goes. But anything from 2 onward, up, okay, that would be to infinity. Okay, that means the graph is starting at +2 on the y-axis, and it's branching out to the right and to the left to infinity. Okay, so we got infinity here and infinity here. Okay, remember when you're going up is positive infinity. If it's going down, then it's negative infinity. This is along the y-axis, by the way. Okay, and that would be the range. So when you do it graphically, it's a little more visual. You got to think a little differently. Okay, because it may not be feasible to plot all the points. Write all the points down. But I want you to think about it. Now, because, when you determine whether it's a function or not, then you do the vertical line test. But when you do the domain and range, you have to analyze it a little more visually, a little more carefully, and that just comes with practice. Okay? And that's it. That's all I have for domain and range, so I'm going to terminate this video. Thank you so much for watching. I know it was a long video, but I wanted to give you a lot of information on it so that you have everything in one video for you. Okay? I hope that this was truly helpful, and when you study this topic in in intermediate algebra, college algebra, or any kind of math course, hopefully this will help you a lot. Thank you so much, and take care.